Good evening. Welcome back to the continuing lecture in investment analysis. We now need to move on to the next topic called, Macaulay's duration. Now, duration. Now let's first define what duration is. Duration is effective maturity. Okay. Now, this is a concept brought up by Frederick Macaulay, and Frederick Macaulay was a Canadian economist. I think I misstated, Burton Malkiel as Canadian economist, but Burton Malkiel was actually American. Frederick Macaulay was Canadian, and Frederick Macaulay was, like a generation ahead of, Burton Malkiel, and also Macaulay did a very, fundamental contribution to theories in bond. And what is duration then? Duration is effective maturity. But what is effective maturity? Now, let's think about this. If you are buying bond, investing in bond, first, you want to value its, you want to price it, rational price, or fair value or intrinsic value, right? Now, and of course, if the market price is, closely aligned with fair value, then you can say market is in equilibrium, right? But in reality, in the short run, it's not likely. But assuming that the market price is also that, and let's say this is, this is a premium bond. Let's say, $1,200, right? And it has 10 years to maturity. 10 years. So time to maturity is 10 years. And the reason, and at maturity, of course, you get the par value of 1,000. So if you are paying premium at this point with 10 years left to maturity, then that means this bond must be paying very good coupon interest, right? But with such, a handsome coupon interest, your question is, how long will it take for you to recover your principal? In other words, because you paid $1,200, and if it pays, 10% coupon a year, it will, just by collecting interest, in 2 years, you already collect, $200, right? Of course, it's not exactly $200 in present value, right? In present value, it may take 5 years or 6 years to recover your principal of 1,200, right? That's effective maturity. You understand? If it takes 6 years, to fully recover your investment of $1,200, right? Of course, you will hold it until if you hold it until maturity, you would collect more. But by year 6, then you will recover all you have invested, and at that point also you sell, and then you get whatever you will still get something, greater than, if the 10% interest is still, coupon interest rate is still greater than, market rate, then you will still sell it above par value. But that is the idea, right? Um, of duration, right? Effect. Uh, how how long will it take, right, to recover your initial investment in present value, right? Now, so then it is basically, it can be expressed as weighted average of time periods, right? Like how many years, weighted average of time periods until each payment, um, uh, how many time periods, with weights proportional to the present value of that payment. In other words, think of it this way. Out of the bond price, right, your the price that you paid, 1,200, um, your your coupons, which is cash flow, right? Right. That coupon payment, um, because it has to be, present value, because at time zero, at present, you pay 1,200, right? So um, it has to be the proportion of the present value of each coupon payment, right, out of the whole bond price. In other words, the earlier the coupon, it weighs in more, because the next coupon payment will discount it only once, and the one after next will be discounted twice. I mean, the farther away the coupon is, it will be discounted more. So the earlier coupons will weigh in more in the calculation of uh, the weighted average, right? In other words, uh, uh, the first bond, right? The first coupon payment out of the entire bond price uh, will be greater than the if this is one, right? And in other words, so hard to write. Oh yeah, yeah. Ah, it's really uh, trying my patience, right? So think about it. If this is one, t is one, right? This is simply the weight of the present value of the first coupon payment out of the your entire bond price that you paid, which would be greater than CF2, present value of CF2, which would be greater than present value of CF3, right? Present value of CF3, right? And so on, right? So think about it. The weight will be the greatest, and so it's the weighted average, right? It's the, it's already weighted, right? Um, so duration is basically, time period one, right? Uh, Times weight, where weight is, and sum of all of that, where weight is, basically present value of each coupon payment out of the bond price. So you can express it also this way, right? It's the present value, right? That's the present value, right? Present value of each, uh, coupon payment at time, uh, multiplied by time period, right? The first, second, third. So that is, in other words, if you rewrite it, it will be a weight of the first coupon payment times one, right? And because it's two times weight of, two, this means, each time period, right? First payment, second payment, third payment, right? And so on. T minus one times weight of T minus one, and T, the maturity, right? Final time period times WT. So this is simply, it's a fairly easy concept. It's weighted average, right? And the weights are basically the present value of each coupon payment out of the bond price that you paid. So Macaulay's duration estimates how many years it will take for an investor to be repaid to recover, right? Uh, the market price of the bond you paid by its total cash flow. And there is also modified duration. So Macaulay's duration is basically uh, the ordinary duration, or standard duration, and modified duration is, it measures the change in bond price given a uh, small change, incremental change in interest rate, uh, which is 1%, 1% change. How much the bond price changes, for 1% change in interest rate. Okay. So actually, let's do this example to find, duration exercise. It's not that difficult. So here, I will switch to Excel file, but let me. I mean, this Excel file is there in your. Let me. Switch to my screen, right? And then now you should be able to see my screen about now. By about now. Why is it taking so long? Yeah. So I'm gonna okay. So you may not be you may not see this. Okay, so let me go back there and oh no, that's not where's the file? It wasn't open. Okay, let me go back and open it. Not this one. I think this file didn't open. Okay, now I think it is. Yeah, it's there. So Okay, this is spreadsheet 11.1, and uh, yeah, there you go. And you can find it also in I switched it to soon. Well, let me show you. Now you see my screen. This is and topic 3, managing bond portfolios, and these files are not visible to you at this time, but when on October 1st, it will be, right? There's there's spreadsheet 11-1, so if you download it, and then okay, and let me switch to okay, there you go. So we'll calculate duration. First of all, 8%, we have two bonds. One is 8% coupon bond, and the other one is 0 coupon bond. And interest rate is 10%. What does that mean? This is this is the discount rate, or the yield to maturity, right? So let me blow this up a little. So first thing, it's got a 3-year maturity, 3 years to maturity, right? So at the end of year 1, you have $80, coupon payment. At the end of year 2, $80, right? And then year 3, you get coupon of $80 and $1,000 par value, right? Let me put to make it more dollar sign. Dollar sign, and this is 0 coupon, so there's no coupon. Now payment is discounted at 10%. We'll have to, right? Because what's the formula? Formula is I have to I will write the formula somewhere here, right? Because duration is what? Duration is basically it's easier to write it this way. Present value of Q cash flow, right? Over price of the bond, right? And where T runs from 1 through N, right? And times time, right? So we are doing that exactly, right? first I will have to find the present values of all of these, coupon payments. So I'll have to discount it for, where is it? Okay, discount this by 1 plus our, discount rate, yield to maturity, and I'll have to lock it because I'm gonna drag it down. Locked, and then I raise it to time, right? And then that's dollars, right? And I drag it down. And I do auto sum, sum everything here, right? Sum, what happened? Using auto sum, right? Sum everything, right? There you go. And also dollars. And then I find weight. And the weight is, weight of each one of them divided by, price of the bond, right? Currently, the price of the bond, it has to be, it has to be obviously a discount bond because coupon rate is less than the coupon rate is less than the discount rate, right? Market interest rate. So it would have to be, and then so you pay 950, and then that should I should lock that. I want to lock it because I'm going to drag it down. To lock it, you got to hit F4, right? Drag it down, and sum of all the weights will sum to 1 because this weight, everything, it's not a dollar, but because it's a pure number, it's weight. So plus number, right? Now I cannot, okay, I heard someone, but I guess this is a private session for, just recording the lecture. And if you accidentally end this collaborate session, I want you to mute your microphone and leave the session because this is, for recording the lecture. Okay, and I would appreciate it. Now, where was I? So then we need to find the weighted average, right? So we will have to weight these cash flows, which is column B times column E, right? This is weighted present value of cash flows, right? So it's simple, this times this, and then you just drag it down. Okay, and of course, I need the bottom. I mean, whenever there is a sum, for you to get the sum, drawing the line, on the line or underscore. This is underline, not underscore. gives like structural demarcation line between the data points to be summed and the result of the sum, right? The sum, in other words, the result of. And then it is also using auto sum, right? There you go, 2.77, and let me increase even, 2.774. That's the duration. In other words, you will fully recover your principal, not in 3 years, in 2.77 years, 774 years, right? So that is the effective maturity, and that's called duration. Now, let's try this for zero coupon bond, and for zero coupon bond, I will. All you need to do is simply, I'm gonna copy that and paste it here, and because it's the same, it's the same process. This is wrong. I have to make some adjustment. First of all, okay, let's see, nothing there. Oh, no. This was, okay, nothing there. And some, right? I have to make some adjustment. It cannot add up to, I mean, all of the weights must add up to 1. So here, let's see, D9, no, that should be D14, and you got a lock. Okay. I mean, when you, okay, and then in a different context, right? I mean, it's the same model, but different context. You have to make adjustment for that context, right? And then there you go. You have the duration of a zero coupon bond is the same thing as the maturity. Okay. Why? Because in a zero coupon bond, there is no cash flow, right? There is no, other than, at the end, other than the face value and maturity, right? So this is an important fact for a zero coupon bond, right? Maturity is the same thing as the duration. So actually, this will serve as a very useful tool later on in the passive bond management, in immunization and rebalancing, and and when we say zero coupon bond, you normally think about $1,000 face value, but of course the bonds standard face value is 1,000, but a zero coupon bond can be customized to fit any maturity value. For example, if the maturity value is 5,250,000, they can issue zero coupon bonds with the maturity value of that, right? So, but then that type of zero coupon bond will come into play with very useful implications. Okay, so this is the very simple exercise of the duration calculation, right? Duration calculation, that rhymes, but calculating duration, right? So that time's up. That leaves us, with no time to spare with this 30-minute video. So I'm going to have to cut off the recording, and uh, we'll see you in the next lecture video. Okay. Thank you very much, and I will see you. Uh, I will see you in the next video. Stop recording.